All right, today we're going to be talking about lesson 5.3, algebraic properties of equality. Taking some things we've already learned and just kind of putting some vocab behind them, and also introducing this idea of a statement and a reason style of proof, which we're going to see so much. We're going to have several vocab words today. The first four are addition property of equality, subtraction property of equality, multiplication, and division. Instead of going through the formal definitions of these and all of that stuff, I think it's going to be best if we just see these in action and kind of see what they look like. First thing I want to show you guys is this idea of a statement and a reason box. The statement is kind of like your problem, maybe what you're trying to solve, what you're trying to prove. And the reason box is just that. It's your reasoning behind the steps that you're taking. So before I kind of jump into this problem, let's rewrite it a little bit and let's just say I said to solve the equation x divided by 3 equals 45. How would we solve for x? Well, we would only have one step. We would need to multiply both sides by 3. That would cancel that out and give us x equals 135. When we're filling in these statement and reason boxes, we're going to kind of be solving these equations and listing out how we did it. So starting off with x divided by 3 equals 45. Like I said, we multiplied both sides by 3 here, and that's kind of how we got down to 135. So in our reason box, we're going to write down what we did. And instead of saying multiply both sides by 3, we're going to use this vocab. And because we multiplied, we'll say we use the multiplication property of equality. Multiplication property of equality. And moving on to number 2 here, we're going to see something very similar. We have x plus 4 equals 3. Again, if I wanted to solve for x here, all I would do is subtract 4 on both sides, get rid of it to give me x equals negative 1. All I need to do to fill in my reason box here is write down what I did to get from that top to the bottom. And then what I did was subtract by 4. So we'll use the subtraction property of equality. And we can kind of go through and use these remaining two to finish these out. So like we see on number 3, we have 3x equals 12. To finish this problem, we would divide both sides by 3. So our reason how we got to x equals 4 would be division. So that's the division property of equality. And then finally, for number 4, we only have one left here. We have x minus 5 equals 30. If I wanted to get that x by itself, I would add 5 to both sides to give me x equals 35. And to that I added, so addition, property of equality. I'm just saying prop here, taking a little shortcut. I'll write the rest of it out though. In some cases, your teacher won't really mind if you use shorthand, if you just say add, prop of equality, addition, whatever. What I would recommend not to do is don't just write like plus, or don't just write add, or anything like that. The whole point is that we're using these properties because we're going to use more and more properties as time goes on. So number 5 and 6, they complete the final step, but kind of working the other direction. So number 5 says x minus 7 equals 42. That's our given, so we're starting with. It says we're using the addition property of equality, but in this case, we might be able to just kind of tell that we need to add 7 to both sides to get x equals 49. And that's our answer. All our boxes are filled in. Number 6 is a good one. Here we have some line segments. These properties work with numbers and segments. We have AB plus CD equals EF plus CD. It says we're using the subtraction property, so that's what we're going to want to be kind of utilizing to simplify this. And if I subtract CD on both sides, boom, boom, it cancels out, leaving us with AB equals EF. Nice and simplified. On the next page, we have a couple of different properties. We have the substitution property, transitive, distributive, and definition of congruence. And these look a bunch of different ways. So substitution property of equality is saying that just like we did with our solving equations last semester, at the very end of last semester, with elimination and all that, if we know what one variable equals, let's say we have x equals 5 and x plus y equals 12, we can take what one variable equals and replace that variable in a different equation. So instead of saying x plus y equals 12, well, I know that x equals 5, so we could say 5 plus y equals 12. Substitution is one of the most common. We see it all the time. So it's all just plugging in one variable that you know. We'll see a lot of examples what that can look like. Transitive is my personal favorite, and that is when you have a couple different things that are equal to each other. So let's say we have A equals B and B equals C. A equals B and B equals C. What we can do is we can kind of combine these things two together, skip a step, and say A equals C. If I know this equals this, and that equals that, because all these things are kind of connected, we can just skip that B and say A equals C. Distributive property of equality is one that we are familiar with. Distributive property says if you have something like A times B plus C in parentheses, you can multiply across that A to be left with AB plus AC, multiplying across. And then the last one, definition of congruence. This one is really common when you're working with angles or line segments. And that is if you have something like, let's say, angle D is congruent to angle F. Remember, the word congruent means the same. It means these two things are equal. So we would say that the measure of angle D is equal to the measure of angle F. These angles are the same, which means they have the same measure. So let's go through and see some of these. These will be a little bit different than what we saw in the front. First one, number 7, is AB is congruent to CD, and then AB equals CD, and I want to see the reason for that. And our reason is that when things are congruent, they are equal. It kind of goes back and forth. So I could say this is the definition of congruence. Next up, number 8, we have two things that are given to us. It says x equals y plus 4, 2x plus 3y equals 12, and then it does this big jump, 2 times y plus 4 plus 3y equals 12. What I'm always trying to do in these questions is see what changes. And what changes from box 2 to box 3 is that instead of an x, all of a sudden, I've got a y plus 4. Where did that y plus 4 come from? Well, x equals y plus 4. So what we did here is we substituted in that y plus 4, meaning we can say that our reason here is the substitution property of equality. Substitution property of equality. Number 9 here, this is one that maybe looks familiar to us. We have 3x plus 7 is our given, and then we can see they kind of multiply that 3 across. 3x plus 21 is what they're left with. Here, that's something we're hopefully familiar with, and that is distributing. So instead of saying distributing, we'll use our property of equality here, and that is the distributive property of equality. Moving to number 10, we have some line segments here. It says JK equals PQ, PQ equals ST, and JK equals ST. So again, let's see what's changing here. We had PQ equals ST and JK equals ST, and I'm seeing two different correct answers. First of all, what I'm seeing is we kind of have this path here, JQ to PQ, PQ to ST. Anytime we see that path, this could be the transitive property of equality. If I know two things are equal, they'll be equal to that same third thing. But you also could write, in this case, the substitution property of equality. Technically, we are just substituting in JK and for PQ, because JK equals PQ, so there's more than one right answer there. Both work just fine. Number 11 gives us a very similar kind of idea. It says the angle P is congruent to angle Q is congruent to angle R, and angle P is congruent to angle R. So we have three angles that are congruent. This means that we can get rid of that middle angle. All three of them are going to be equal to each other. Or another way to say that is we're going to be using the transitive property. Substitution is also correct here. And then last one here, we have the angle A is congruent to angle B, and the measure of angle A is equal to 30 degrees. So the measure of angle B would also be 30 degrees. We know these two are the same. We know they are congruent. They're both going to equal 30. So our reason here would be the definition of congruence. As we kind of begin to see some longer proofs, and if you kind of flip forward in your notes, you can see that these statement and reason boxes get bigger and bigger. These ideas become more and more concrete. It kind of can be a little bit weird just seeing them in these one-step questions. So we'll get more and more familiar with this vocab as we go along. Have a great rest of your day.